Kia ora koutou. This is a quick video doing a differential equations question for Arian, and it's from the May-June 2025 papers, and it's paper 33. Right, we've got x and y that satisfy this differential equation, and then we've got a condition that when y is equal to pi on 12, x is equal to pi on 2, or the other way around. We have to solve the DE, obtaining a relation between x and y. Now, I wasn't sure exactly what they were looking for in that wording, but so I went right through and made y the subject, but it turns out you don't need to go quite that far, but it wasn't a difficult last step anyway. And then we have to find values of y when x is 0, given that y is between 0 and pi on 2. Okay, so let's have a look at the DE and just see what we've got to do. All right, so sine of 4y dy by dx is equal to x sine 2y sine 3x. So pretty much as soon as I write it down, I guess I notice that I've got a sine of 4y here and a sine of 2y here. I'm going to separate the variables, but I'm already thinking about a double angle sine thing going on. So we get sine of 4y over sine of 2y dy is equal to x sine of 3x dx. And we're going to integrate both sides. Okay, so looking at the right-hand side first, x times sine of 3x is going to be a fairly straightforward integration by parts thing. And then we've got some compound angles, double angles that we can work with on the left-hand side. So I'm going to rewrite the left-hand side as 2 sine 2y cos of 2y over sine of 2y dy is equal to the right-hand side. So I'm going to start out on the integration by parts here. The x will be what we leave in the first part and then differentiate in the second part, and the sine of 3x will be the thing that we integrate both times. Now the reason I'm doing that as usual is because when I differentiate the x, it's going to go to 1, leaving me with a pretty simple integral in the second part of my IBP. Right, now looking at what we've got here, just move the screen. On the left-hand side, we've got sine of 2y over sine of 2y. So that's nice. We have 2 cos of 2y dy is equal to, let's see, right. You're going to have x times, leave a gap for your coefficient, cos of 3x. That will give me, when I differentiate this, negative 3 sine of 3x. We don't want the negative 3, so we're going to times it by negative 1/3 plus the integral of 1 times, oops, no x there. And I'm going too fast. Right, let's slow down. So minus negative 1/3 cos of 3x dx. Okay, on the left-hand side, when we integrate this, we get a sine of 2y term. And here we have negative 1/3 x cos of 3x plus 1/3 times the integral of cos of 3x. Well, that's going to be sine of 3x times 1/3 to undo the chain rule 3 that comes out here, and I've got plus c. So we have sine of 2y is equal to negative 1/3 x cos of 3x plus 1/9 sine of 3x plus c. Now we're given a condition so that we can figure out what the constant is. When x is pi on 2, we've got y is equal to pi on 12. So let's see what multiples of x and y we need. Well, we're going to need a 3x here. 3x is equal to 3 pi on 2. And we're going to need a 2y here. So 2y is equal to pi on 6. So here's my very wobbly triangle. So sine of 2y, we get sine of pi on 6 is equal to negative 1/3 x cos of 3 pi on 2 plus 1/9 sine of 3x which is 3 pi on 2 again, plus c. Right, sine of pi on 6 is 1/2. And here we've got, did I write x? Sorry, that shouldn't have been an x. That needs to be a pi on 2 in here. So let's see what some of these cosines and sines are. There's my cosine graph. There's my sine graph. Cosine of 3 pi on 2 is 0. And sine of 3 pi on 2 is going to be -1. So c is equal to 1/2 plus 1/9, which works out to be 9 plus 2 is 11 on 18. Right, what does that give me all up? Let's just shrink it a bit. Okay, so we have sine of 2y is equal to -1/3 x cos of 3x plus 1/9 sine of 3x plus 11 over 18. Now, the mark schedule was quite happy for you to leave it like that. I'm guessing because you do have, you've got your y's here on the left-hand side and you've got your x's all over here. So I went further and did a sine inverse thing, but we don't need to do that. Let's look at this last bit of 2 marks. We have to find the values of y when x is equal to 0, when y is in our first quadrant. So I didn't use general solutions here because I felt like that was kind of way more than I needed to do. So we've got y is in quadrant 1, and we want to know what's y when x is equal to 0. So looking back to my DE, here it is here, substituting into here, sine of 2y is going to be 0 plus 1/9 of 0 is 0 plus 11 on 18. So we're solving sine of 2y is equal to 11 over 18. So I found it useful, as usual, to draw a graph. And I'm drawing the graph of sine of 2x here. The period of sine of 2x is only pi, and that means that the values we're looking for are going to be, I don't know, here and here, but this value is pi on 2. So I'm going to start by finding a principal value. So the angle whose sine is 11 on 18 will be 0.6575. So that's giving me 2y is equal to 0.6575. So my first value of y will be 0.3287, which to 3 significant figures is 0.329. Okay, so we've found this one, and I'm going to find this one using the symmetry of the graph. So I've gone in that far here. I'm going to come out this far here. So the other value will be y is pi on 2 minus 0.3287 blah, blah, blah. So y is equal to 1.24 to 3 significant figures. So there you go. We've got 2 solutions, 0.329 and 1.24, and we've solved our differential equation. Thanks for watching. If you've got any last minute questions this weekend, remember just to send them in and I'll try and YouTube them for you.